When I told you that the price of these malware analysis sandboxes can be high, I have tried it on Google, and it turned out that the cheapest ones are at around 10,000 US dollars, but the high-end ones with the most throughput can be like 300,000 US dollars. That's the first initial investment, and after that it can be up to 100,000 US dollars per year. And if you think about that, for the same price you can buy this company car, well, it's a hard decision, you know. Now, let's meet the hero of the hour, and his name is Trevor. And Trevor is the Chief Information Security Officer at Acme Corporation. And Trevor has a problem. He knows that his network is not really up to the newest malware trends, so he really has to detect all these new malware samples. And a lot of vendors are trying to sell him these malware analysis sandboxes. And the first vendor can tell him that, hey, we have detected the most zero-day exploits last year, we are the best on the market. Or others can say, hey, we are the most expensive, so we are the best, we promise you. Or some others can say, we are the cheapest, so you can be still compliant and save money and buy the company car. So it's hard, really hard for Trevor to choose the best appliance. And Trevor is really sad because he doesn't know that what should he do. And as it turns out, there is an easy way to solve this dilemma, because it is possible to test these malware analysis sandboxes, such as every product can be tested, this can be tested as well. And there are many aspects how malware analysis sandbox can be tested. And during my presentation, I will focus on one key aspect of it, which is the anti sandbox solutions, which I will tell you about later what it really is. But the thing is that if a lame malware can evade the dynamic analysis and all the other magic in these boxes, then how can we be sure that these boxes can prevent really advanced and targeted attacks? Now, the question is that, for example, if you are a penetration tester, then why is it good for you to implement these sandbox evasion methods? Because you really don't want to get busted on the day one when you have nothing from the network, you have not reached any key targets. And if this malware analysis sandbox picks your malware, you are busted and you have to start over again. Also, from time to time, penetration testers can get lazy, so they will reuse their code, but if it's once flagged by a sandbox, it will be propagated in the security industry, it will be flagged at the next engagement, you have to start over your work. So you really need something to hide in the shadows. Now, how many of you have played with Command & Conquer Red Alert? Okay, so whenever you started playing it, one of the first things you did, that there was a scout, and you sent your scout to map the area where your enemy is, what is his capabilities, how you can attack him. At the beginning of the game, you will using just some plain soldiers. Later, maybe you have this cool spy plane. But the thing is that when you implement your atomic bomb and you drop it, you don't drop it randomly on the map. You really know where you want to drop it because it's expensive, it's a one-time shot, and you really have to know where your target is. And all these sandboxing and anti-sandboxing techniques are about knowing the target and knowing what you want to attack. So all the malware implements nowadays these sandbox detection techniques, at least the advanced ones. And what they do, that they try to detect, for example, that there is a virtualization in use, like VMware, VirtualBox, and so on. And whenever they detect that they are running in a virtualized environment, they will change their behavior. Usually they just quit, so there is no behavior at all. Or I have seen some other malware, which was, for example, financial malware, but when it was running on a malware analysis sandbox, it looked like an adware. So this can be tricky sometimes. But the thing is that nowadays, from the malware perspective, there is too much focus on detecting virtualized environments. So for example, on the left screen, you can see a remote access Trojan builder, where you can checkbox all the different anti-sandboxing methods. So whenever you or a script kiddie builds this new rat sample, then this sample detects that it's running in the checked environments, it will immediately quit. But the thing is that good guys are working as well, and some products realize that if they emulate a virtualized environment, this malware will self-terminate itself. So in this page you can see that I have started my rat sample on this system where this defensive software was installed, and it emulated that it is actually VMware, and it also detected that the rat tried to detect that it is a VMware. So this virtualization detection is kind of all stuff. This screenshot is from the Hacked team wiki pages, and if you follow the Attila Marosi presentation, then you might be familiar with these things. What they were using the exact same methods as I already outlined, that they had a so-called scout module, and the scout module was checking all the hardware information of the operating system, like which CPU architecture is used, how many RAM is in the box, what are the installed applications, and so on and so on. And you cannot really see on this slide, but they also tried to detect all the different virtualization methods like VMware or VirtualBox, and they were using VMI queries in order to do that. Actually, they have used such VMI queries which were not known previously, so all the sandboxes were not flagging these VMI queries malicious. But again, the problem with detecting virtualization is that nowadays there are completely free and open source solutions to harden, for example, a VirtualBox in a way that malware cannot detect that it is running in a virtualized environment. For example, I have compiled this hacking team sample, and I run it in my hardened VirtualBox server, and it was not detecting that it is running in a virtualized environment. Now, in order to test these malware analysis sandboxes, I have created a malware, and I uploaded this malware to an awful lot of different public and non-public malware analysis sandboxes. And this malware checked many different aspects of the running environment. I'm going to show you some of these later. And the best case scenario is when the malware analysis sandbox can directly talk to the internet, so it can interact with my HTTP server, so I can exfiltrate all this information from the sandbox directly. Or it was sometimes the case that direct communication to my web server was not possible, but still the appliance tried to resolve all the DNS names and resolve it to IP addresses. And for example, let's say I own the DNS server for mydomain.com, and in this case my malware was querying like Microsoft Office 2012 is installed on this host.mydomain.com. And in this case, I was able to leak and exfiltrate all this data from the malware analysis sandboxes. And there is no live demo, but I have a video. Malware.com is a famous cookie-based malware analysis sandbox. It's a great project, it's free, and I use it sometimes as well because it works. And I have uploaded my malware to this public sandbox. And here is my HTTP server running, which receives all the data from the malware analysis sandbox. And you can see, for example, the screen resolution here, or you can see, for example, that Oracle VM VirtualBox is installed, what kind of CPU has been used, and all these different interesting things. For example, here you can see that the mouse position at one time was at these coordinates, and some minutes later it has been changed to this one. So this sandbox is basically emulating mouse events, for example. Sorry?
And it's a virtual.
Yes, for sure. But when I checked the result of the analysis, because I have checked for many different things, it will flag my malware as malicious because it's employing already known sandbox detection techniques. Now, on the next slides, I will use these two different icons, and if it's a big red one, it means it has a good sandbox detection effectiveness. So this technique is very good to detect the sandboxes, and if it's a big trap, it means that it is very possible that the sandbox will detect this technique as malicious. The first statistics is from a browser usage statistic about the average web user on the internet, and as you can see, it's basically less than 7% of the total users who use 1024 multiplied 768 or lower resolution. And the good thing about screen resolution is that you can even, as an attacker, you can query it through the web browser. So even before the exploitation stage and before you drop your malware onto the box, you can detect some of the sandboxes. And as it turned out, the sandboxes has huge problems with screen resolutions because a very huge number of these sandboxes were using very low screen resolution, I mean, who's using 640 multiplied 480 nowadays? So this was really a huge problem. These are typical tools you cannot find on user desktops, but what you can find on malware analysis sandboxes. And the best one is the last one, called VE-Ware tools. And the story about this is that some malware implemented automated checks to search for VMware tools installed. So the sandbox developers reacted to this, and they have renamed VMware tools to VE-Ware tools. But if you leave this information to your server, you can be damn sure that this is a malware analysis sandbox. Again, these are some of the processes you cannot find on average desktops, but you can find on malware analysis sandboxes. Different sandboxes use different things like fake HTTP server or behavior dumper. I think this is really easy to spot that this is not a real user workstation. This is one of my favorite. I have checked the processor types of the sandboxes, and it turned out that even when the sandbox tried to disguise that it is in a virtualized environment, the processor type was telling it to me clearly that this is not a user desktop. I mean, users don't usually use Xeon processors or quad-core processors, and it was really funny to see very old and ancient CPUs like Intel Pentium Pro or Pentium 2 processors. But it turned out that some of the malware analysis sandboxes used real desktop CPUs, or at least faked it. So this is not a best way to detect it, but it's a very good way. Nowadays, even some of the tools, like the social engineering toolkit, implements the method that it checks the number of cores of the processor, and if it's 1, it is usually either very old hardware, which might be not your target, or it is a sandbox. I have seen some examples where 2 and even one example where the malware analysis sandbox used 4 cores. It was pretty funny that it was from Ukraine. At least they have the money to do that. I have also checked the computer system property, and if you see box, it's damn sure that this is a malware analysis sandbox. Some of them were server platforms, which again, if you are targeting users through your exploit kit, it is highly possible that this is not a user workstation. And when I counted all these properties, it turned out that almost 70% of the environment was virtualized. Less than 20% was looked like a desktop, and around 14 looked like a server. It turned out that almost 80% of the malware analysis sandboxes have no mouse activity at all, and only 20% of them faked the mouse movement. But even if there is no mouse movement, if you check the coordinates of the mouse and you see that it's either in the 0, 0 position or 600, 600, you can be sure that this is not something which has been used by a user recently. Memory size. I was quite amazed that there are malware analysis sandboxes with 128 megabytes of memory. They were running XP. I never knew that it can run on such a low amount of memory. And it turned out that because memory is more or less expensive if you try to run multiple instances of these malware analysis sandboxes. So most of these sandboxes were very low on memory compared to average user workstations. I believe most of them have at least 2 GB right now, which is very common. And there were some sandboxes having 4 GB of memory, but it was only some few exceptions. The machine name? Yes. So I think we can split the beer. I have two. So it was just fun to see how the developers named their sandboxes. I mean, it's really not a good idea to name it Sandbox A, for example, or WhenXP Mall Test, because it's a dead giveaway, but it was more or less randomized. Now, this is a real screen capture from a malware analysis sandbox. And I want you to help me to identify why this is a malware analysis sandbox and not a user workstation. Give me a hint.
Where is the mouse?
You cannot see the mouse on screenshots usually. Yes, only 3 icons. That's very simple. This is not a user workstation. Yeah, default background. Yes. Sorry. Yes, no application is running at all. Yes, anti-recycle bin. So there are so many things on this picture. On this picture, they didn't even try to hide that there is an analysis going on. And again, this is another example where they really don't want to hide that what's going on at all. And I mean, this is how a real user workstation looks like when he's busy working. Actually, I have still these screenshots from the hacked team torrent when they were hacked. This is actually real user screenshots from one of their administrators who was busy working. So if you see this, you know this is not a sandbox at all. I had this idea to check for the number of pen drives or flash drives used in the operating system. And it turned out that some of the sandboxes have used flash drives, but only in a few cases at all. And even if I checked how many, usually it's a maximum 1. But in a real user workstation, you can see at least 10 different flash drives in the past 1 year. And I have also checked for a printer, as almost every user workstation has printers. But it turned out that no malware analysis sandbox has a printer at all, except the default installed ones like Adobe or Office or something. So this turned out a very, very effective way to detect sandboxes. There are hundreds of other aspects I have checked, and these turned out not to be very effective. I also checked for recently modified files in popular places like the user desktop, documents folder, app.data temp. And it turned out that when we are talking about sandboxes, it is usually less than 3. And if you look at your workstation, it's definitely more than 3. If we look like the last modified files in 1 week. I have also checked the IP addresses whenever I had a direct connection from the sandbox to my HTTP server. And there is a good analysis from TrustWave where they have checked one of the exploit kits, and these exploit kits and also some of the CNC servers, they have a very huge blacklist of both IP addresses and IP ranges. And whenever a connection is coming from that specific IP range, then they will just deny connection. For example, a whole Google block is totally blacklisted, which means that if a malware analyst from Google tries to connect to these exploit kits or CNC servers, they will see as the CNC server is down. But actually it is running for everyone else on the world, but not for them. And there are basically 3 different layers where you can implement your sandbox detection techniques. And all layers have its pros and cons. Like if you implement it in the malware itself and it's an automated decision, then it is very good for you because you don't have to leak any information or data to your CNC server, so you don't reveal your CNC server, but not many things you can implement in the malware itself. Also, you can do the decision of whether it is a sandbox or not on the CNC server via automated ways. If you leak data and your server correlates everything, then it can be much more powerful than in the malware itself. But in this case, you already revealed your CNC server. And one of the most powerful ways is when there is a manual analyst looking at all the information which has been extracted from the running environment, and this manual analyst can decide whether this is the real target or this is just a malware analysis sandbox. Like, for example, creating screenshots when there is some activity on the machine, and checking 3 different screenshots after each other, you can really tell whether this is a sandbox or this is a real user workstation. And actually it is the best if you implement all of the 3 layers and you stop the execution whenever first the sandbox is detected. And if you are a penetration tester or you are a black hat, you really have to know who is your victim. I mean, do you want to run on a machine which is on Xeon processors? This is probably not. Or if you are targeting, for example, a top CEO of a big company, and you see there is Pentium 2 and 128 megabytes memory, do you believe it that this is really your target? And also, when I prepared my slides, it turned out that one of my techniques I invented has been implemented by the black hats before I gave my presentation. This is the OS uptime, because most of the sandboxes start just before the malware analysis begin. So by checking the uptime of the OS, and if you filter out, for example, less than 2 minutes, you can filter out most malware analysis sandboxes because they just started. And there are hard problems if you are into developing malware analysis sandboxes, which is really hard to solve. One of the problems is the sleep function. Some of the sandboxes emulate the sleep functions, others not. And if the sandbox doesn't emulate the sleep function, it is a very old technique that the malware will sleep for typically 5 minutes and only do any activity after the 5 minutes. And in this case, all the behavior analysis will be bypassed. And some of the sandboxes simulate the sleep event, so it will return the malware that 5 minutes already passed, go on. And the thing is that there are thousands of ways to detect this activity. for example, by starting 2 different threads, and one thread does huge CPU computation while the other sleeps, and this way you can know whether the sleep was emulated or not. And some sandbox developers started the idea of continuous sandboxing, where the sandbox is not reverted or resetted or rebooted at all between the malware samples, and this can defeat this problem with the sleep function, but again, this continuous sandboxing has its own problems. The other hard problems for malware analysis sandbox developers is the network connection. Are we going to allow the sandbox to interact with the internet or not? If the sandbox can interact with the internet, just leak some data like multiple screenshots and decide on the server whether this is a sandbox or the victim. Or if there is no HTTP connection to my attacker server, it can mean that it is an air-gapped machine, and it is possible that my attack was via the internet. So how can it be that it is now air-gapped? So again, you can be sure that this is a malware analysis sandbox. And that is the case when the sandbox simulates the internet, so it will give back fake data. Actually, there are some great tools out there, but again, if the internet is simulated, there are easy ways to detect this simulation, like downloading a known object like favicon, for example, from a popular website, calculating the hash of the favicon, and if it's different, then we can be sure that this is not the real internet, but this is simulated one. And I had my own lessons learned when I created this malware, and it turned out that even if my malware runs on a default Windows XP Service Pack 2 or the latest Windows, it doesn't mean it will run on a malware analysis sandbox. And I have seen a lot of crashes where my malware sample just crashed. And I don't know why, that's strange. Also, there were size limitations. These were usually free public sandboxes, so it's more or less okay. And I have seen some of the sandboxes that they tried to analyze the parent process, but whenever my malware dropped a new process, it was not analyzed at all. I have seen cases, my malware runs in a multi-threaded mode, and I have seen cases where only one thread was running and not the others. I'm not sure what happened there. Maybe there was a manual analysis, I don't know. So there were strange things during my experiment. And if you are a penetration tester or a malware writer, you have to know that there are very easy ways to evade these dynamic analysis of these products. And although manual analysis is basically impossible to defeat, but with the more and more samples used, manual analysis cannot really keep up with all the load of the work. If you are a sandbox developer and you are selling your sandbox for these very high prices, my recommendations is that you should really implement more and more anti-sandbox solutions, because it is very easy to detect that it is a malware analysis sandbox. And I believe one good way to increase the detection capabilities of these sandboxes is to dump a real user workstation and keep it updated with user behavior, for example. And if you are working for a company and you are on the blue team defensive side, you really should test your malware analysis sandbox before you want to buy one, because the capabilities are very different from sandbox to sandbox. And most of the sandboxes give you the possibility to upload your own configuration, which can be, for example, the golden image used at your environment, and I really recommend to do that, because your sandbox has to really look like your real user workstations. And you shouldn't trust the marketing and the sales department, because they sometimes lie to you. But the thing is that there are really some good malware analysis sandboxes out there. And after a proper comparative assessment, Trevor can finally choose wisely which product to buy instead of the company car. So the question is, do you think, should I release my code now, so all of you can detect malware analysis sandboxes? Yes? Okay. So this is my GitHub page. Make public. It's a long one, so I will do that later. I promise. So you will find some of the basics about sandboxing, anti-sandboxing, and anti-anti-sandboxing on these links. I really recommend you to check these. And thank you for your attention.